Okay, so this is the formal proof. He goes over this in the video. So if you have your notes out, you've been filling in the blanks, or following along with the statements that we've reviewed to prove triangles congruent. So this is a formal proof of amplified parallelogram theorem. So pretty much stating that you can prove that PR, so the sides of opposite sides of a parallelogram are congruent to one another. So GL, forgot to draw on this line, and that RG is congruent to LP. So this is the reasoning behind the APT, or the amplified parallelogram theorem. So our first thing is we want to look at our given, what we're supposed to be proving, and our figure. So we're given a parallelogram that's stated in our theorem, or given, that PLRG, so GR, is a parallelogram. And well, we need to prove that the opposite sides are congruent. So that's pretty much all we're given. So let's start with our first given statement. So PLGR is a parallelogram. I'm going to shorten that. And the reason is because it is given. So what can we say about a parallelogram? Well, we know that the opposite sides are parallel. That's the definition of it. Two sets of parallel sides. So PL is parallel to GR, and PR is parallel to LG. So PL is parallel to GR, and PR is parallel to LG. And that is because that's what the definition of parallelogram is. So definition of parallelogram is our reason that we know that those opposite sides are parallel to one another. So because those are parallel, what do we have going across this PG? So it's a line, but it's cutting these angles right here. So it's acting as a transversal, creating alternate interior angles. So our alternate interior angles, making sure that we're lining up our corresponding parts, is LPG, and then RGP. So we can say that these angles, angle LPG is congruent to angle RGP. So notice I'm starting the opposite sides, coming to G, and then going back out. So make sure that you do have the corresponding parts correct. The LPG is congruent to angle RGP. And that is because of alternate interior angles. Because the lines being parallel, cut by transversal, they are alternate interior angles, and they are congruent. So we have an angle there. Well, it cuts both sides of parallel lines, so we can also say that RPG is congruent to LGP. So RPG is congruent to LGP, which is another angle. And that's because they are also alternate interior angles. So remember, this is because those lines are parallel. We know that because we are given that this is a parallelogram. They're cut by this transversal, so making those angles alternate interior angles. You want to make sure that you're doing the corresponding parts with each one. So RPG and then LGP correspond to one another. So they're going to be congruent. Next, so we have two angles. What else could we use here? So remember, this lesson is over angle, side, angle. So we're going to look for a side. I don't think we can figure out what the other angle is, and that hasn't even been a proof that we've worked with. So our side that is in between these two angles is right here, PG. And we can say that that is congruent to itself because of the reflexive property. So we've established an angle, side, angle. So now we have proven that PG or PRG and GLP are congruent to one another because of angle, side, angle postulate. So triangle PRG is congruent to GLP. Now, this proof is different. We're not told to prove that triangles are congruent. We're told to prove, I know it's going to be hard to see at the very end, so I'll try to keep it small. But we weren't told to prove that these triangles are congruent like we did in the last lesson. Instead, we were told to prove that the opposite sides are congruent to one another. So, based upon what we just said, corresponding parts of congruent triangles are congruent. So we've established that these triangles are congruent. The parts that correspond are line segment PR, that corresponds to GL, and RG, line segment, corresponds to LP. So we can say that both of those line segments are congruent to one another because corresponding parts of congruent triangles are congruent. So that's our final reason. So this establishes the whole amplified parallelogram theory, which now you know, and you can just simply write APT given to prove that.